In this lesson, we will find several Laplace transforms, and then find several inverse Laplace transforms step by step. First, let's list a few key Laplace transform formulas we will use. Example A. Find the Laplace transform of 2t cubed minus 4t plus 5. We will use linearity. The Laplace transform of a sum is the sum of transforms. For 2t cubed, use the power rule. For negative 4t, use the power rule with n equals 1. For 5, treat it as 5 times t to the 0. So the final Laplace transform is 12 over s to the fourth minus 4 over s squared plus 5 over s. Example B. Find the Laplace transform of 3e to the negative 2t minus 4 sine of 2t. The transform of e to the at is 1 over s minus a. Here it equals negative 2, so the denominator becomes s plus 2. For sine of 2t, the transform is b over s squared plus b squared, with b equals 2. So the final Laplace transform is 3 over s plus 2 minus 8 over s squared plus 4. Example C. Find the Laplace transform of 2t to the fourth times e to the negative 3t. This uses the shift property. Multiply by e to the at shifts s to s minus a. Here it equals negative 3. So s becomes s plus 3. First transform 2t to the fourth, which is 2 times 4 factorial over s to the fifth. Then replace s with s plus 3. Example D. Find the Laplace transform of 5e to the 2t times cosine of 3t. We use the shift property again. The transform of cosine of 3t is s over s squared plus 9. First take the transform of cosine of 3t, then shift s to s minus 2, and multiply by 5. Now, let's switch to inverse Laplace transforms. Inverse example, A. 5 over 2s plus 1. We want the form 1 over s minus a. Factor out the 2 from the denominator. 5 over 2s plus 1 equals 5 over 2 times 1 over s plus 1 half. So the inverse transform is 5 over 2 times e to the negative 1 half t. Inverse example B. 12 over s to the fourth. Match it to the power rule. N factorial over s to the n plus 1. We need n plus 1 equals 4, so n equals 3. Then n factorial is 6. So 12 over s to the fourth equals 2 times 6 over s to the fourth, which corresponds to 2t cubed. Inverse example C. 4 s over s squared plus 9. This is the cosine form, where b equals 3. Since the numerator is s, we match cosine. The inverse is 4 cosine of 3t. Inverse example D. 3 over s plus 2, all to the fourth. This matches the power rule with a shift. We use n plus 1 equals 4, so n equals 3, and n factorial is 6. So we write 3 as 1 half times 6. Then apply the shift, e to the negative 2t. Great work! We used linearity, the power rule, the sine and cosine transforms, and the shift property to handle all examples. Keep practicing, and these transforms will become second nature.